introduce the definition of decreasing concave up, concave down, and we give a result how to find the function is increasing or decreasing. Okay? So here first, now increasing means what? Increasing, okay? Increasing. For example, on an interval AB means f if x1 less than x2, yeah, for any x1 less than x2, for any x2 belongs to AB. Yeah, if x1 less than x2, we have what? We have fx1 less than fx2. Yes. So the definition of increasing. So decreasing on AB means if fx1 less than x2 or any x1, x2 belongs to AB, we have fx1 greater than fx2. Yeah. And concave up and concave down. So, what's the definition of concave up or concave down? For example, concave up. Concave up, we have two. For example, four graphs like this. Okay, four graphs like this. We can see the graph actually is less below the touched line, yeah? So this is the touched line, so this is the touched line. This is the touched line. So we can see that the graph less below the touched line. So for this case, we call it what? Concave down, yeah? Concave down. And for graph like this. For this graph, we can see the graph is less above the touched line. So for this case, we call it concave up. Concave up. And we say that if a function increasing means what? Increasing how to find a function is increasing means that if the derivative, the derivative greater than zero, yeah, greater than zero increasing, yeah. So less than zero. If the derivative less than zero means the decreasing, yeah? And concave up. So if the second order derivative, okay, second order derivative is greater than zero, we say it's concave up. And if the second order derivative less than zero, we say it's concave down. Okay, concave down. So this is the decreasing concave up, concave down, and we introduce a point that means inflection point. Inflection point. So what's the definition of inflection point? What's the definition of inflection point? Means a function. Here is a point y. While a function point y, the concavity. Y the concavity or the direction of concavity changes. So here, inflection point. Okay, inflection point. The definition is a point where the direction of concavity changes. Okay. So here, if here this is a point x0, on the left is the concave arc. For example, for here is a concave arc. A point left is concave up, right is concave down. Concave down. Then if a point left is concave up, right is concave down. This point is an inflection point. Yeah. Or if left is concave down, right is concave up. Right is concave up. This point also is an inflection point. Yeah. Also is an inflection point. So now, okay. So here, now let's see an example. For this example. For a function fx equal to x cubed, okay, x cubed. For this function, okay, we need to find the increasing interval, the decreasing interval, and the concave up interval, concave down interval, and the inflection points. Okay, inflection points. So the first, now we need to find the increasing interval and the decreasing interval. So we just need to find the first derivative. Okay, the first derivative. So here f derivative equal to what? Equal to x, 3x squared, yeah? 3x squared here means what? Here means this is greater than 0, yeah? It's greater than 0. So here first we, the same, okay, it's the same. Now we let it equal to 0, we let it equal to 0. So here we find that x equal to 0. X equal to 0. So the point 0, we have two paths. So firstly is the left. Yeah. So here is 0. So the left is the interval is minus infinity to 0. Yeah. So the second is 0 to plus infinity. So here we can see the intervals is here is minus infinity to 0, and here is 0 to plus infinity. So intervals and the derivative. So the derivative, okay, the derivative on this interval, when x belongs to this interval, 3x squared is greater than 0, yeah. So here is greater than 0 means it's plus, yeah, it's plus. So here the conclusion is increasing, yeah, yeah.
From
Minus infinity to 0 because for here this is the 0. We let the first order derivative equal to 0. We find x equal to 0. This point, yeah. This point decomposes the whole x coordinate into two parts. The first part is minus infinity to 0. The second part is 0 to plus infinity. So here the first interval here, okay. So the first interval here, when x belongs to this interval, x derivative greater than 0. And when x belongs to this interval, 3x squared is also greater than 0, yes? So here is also plus, so it's also increasing. So this is the increasing interval, okay? The increasing interval. So now for the concave up and the concave down, for the concave up and the concave down, we need to find what? The second derivative, yeah? So the second derivative, here is the derivative. F prime equal to what? Equal to the derivative of this function. 6x, yeah, 6x. So the same, okay, with that the second order derivative equal to 0, so here we obtain x equal to 0, yeah? X equal to 0, also we have two intervals. So here, now we can see the intervals. The first is minus infinity to 0. So here is the second order derivative, and here is the conclusion. So in this interval, f prime, so is positive or negative? Of course, it's negative, yeah. So here is negative. So negative. So here means concave up, concave down, yeah. So concave down, and here in the second here is 0 to plus infinity. 0 to plus infinity. Here in this interval, 6x is greater than 0 or less than 0. Of course, it's positive, yeah. So here is positive. So here is concave up. So now we can see that at the point 0, left is concave down, right is concave up, yeah. Left is concave down, right is concave up. So the inflection point is what? So the inflection point is 0, yeah. Is x equal to 0, yeah. Is x equal to 0. So this is the increasing interval and the concave interval and the inflection point, okay? Yeah.
Can you give us an example where the of given sinus and cosinus of
Sine, cosine?
yeah.
Uh,
It is more difficult than that.
so I no. So you think it's easy here? So now I give a more complex. Now let's see this example. For this example, fx equal to sin 2x. Sin 2x in the interval, in this interval, okay, in 0 to pi, in this interval, okay. In this interval, we need to find the increasing interval, decreasing interval, concave up, concave down interval, okay, and the inflection point. Actually, we can plot the graph, okay. We can plot the graph. So the graph actually is here is x, here is y. So here is pi. Here is 1 half pi. So this is the graph, okay? Now, so the same, okay? Now we need to find the first order derivative. F prime equal to what? Sin prime cosine, yeah? So here is cosine 2x. And 2x plus 2. So the prime is 2 cosine 2x, yeah? 2 cosine 2x. So here, now, for this interval, so we need to find for this function, okay? For this function in we we let it equal to 0. We let it equal to 0. We let it equal to 0. In this interval, we can find x equal to cosine what equal to 0? So now, okay. Now first we record the cosine graph. Cosine like this. Okay, here is 2 pi. So cosine what equal to 0? First cosine here is what? Here is pi. So here is 1/2 pi. Yeah. Here is 2 pi by 3 pi by 2. Yeah. So here actually 2x equal to what? Equal to 1/2 pi or 3 pi by 2. Yeah. So here we know x equal to what? X equal to pi by 4 or 3 pi by 4. Yeah. So here in this interval, this interval is here is 0, here is pi. So 0 to pi. So here is pi by 4. Here is 3 pi by 4. 3 pi by 4. So these 2 points decompose this interval to 3 parts. The first part is 0 to pi by 4. The second part is pi by 4 to 3 pi by 4. The third part is 3 pi by 4 to pi. So now we can see the intervals, and the f prime and the convolution, and the convolutions. The first interval is 0 to pi by 4, 0 to pi by 4. Okay. In this interval, we can see f prime is greater than 0 or less than 0 in this interval. So we just, okay, I think it's easy. For here, you just need to find a value in this interval. For example, pi by 8. So pi by 8, and we substitute the pi by 8 to here, we can see it's positive or negative. So 2 times pi by 8, we choose a value, okay? We choose a special value in this interval. Choose a special value in this interval, pi by 8. So pi by 8 and substituting pi by 8 here. So 2 times pi by 8 is pi by 4. Cosine pi by 4 is what? Is it positive or negative? Positive, yes. So here is positive. So here means in this interval is increasing, yeah? And now here the second interval is pi by 4 to 3 pi by 4, yeah? Pi by 4 to 3 pi by 4. So in this interval we can see is so of course the same, okay? Here we choose a special value. We choose a special value in this interval. For example, 1/2 pi. Yeah, 1/2 pi is here. 1/2 pi, and here 2 times 1/2 pi. 2 times 1/2 pi is pi. Cosine pi is -1. Yeah. So here is minus. Yeah, minus. So minus. So here is decreasing. Yeah. Decreasing. And the third here is 3 pi by 4 to pi. In this interval, okay. In this interval, so here, for this interval, we choose a. In this interval, we choose a special value. For example, 7 pi by 8. 7 pi by 8. 7 pi by 8 in this interval, yeah. 7 pi by 8 and substitute here. 7 pi by 8 times 2, so it's 7 pi by 4. Cosine 7 pi by 4 is positive or negative?
Positive.
So here, 7 pi by 4 actually is here, so it's positive.
Yeah.
So it's positive, so here is positive, so here means it's increasing. So now we can see in 0 to in this interval increasing, decreasing, increasing, okay? So now I think that you are not familiar with the sine or cosine. So the sine or cosine for this function, okay? Sine, cosine for a special angle, okay? For special angle, for 0, pi by 4, 1/2 pi, 3 pi by 4, pi, 5 pi by 4. Okay? So I think that you should to be familiar with this. Okay? So sine, cosine x, sine x. For this two function, okay, and this 0, pi by 4, and 1/2 pi, 3 pi by 4, and pi, 5 pi by 4, and 3 pi by 2, and 7 pi by 4, and 2 pi, okay? At this 9 angle, okay? At this 9 angle, I think that you should be familiar with the wheel of the sine, cosine, okay? So I think that you can to remember the graph. So this is the increasing interval and the decreasing interval. Now let's see the concave up, concave down, concave up, and concave down. So here is the same, okay? We need to find the second order derivative, f prime, okay? So f prime equal to what? Equal to 2 times cosine derivative is what? Minus sine, yes. So here is the minus sine 2x. And the 2x derivative, 2, so times 2, yeah? So the result actually is minus 4 and sine 2x. It's the same, okay? We let it to 0. We let it equal to 0, we find x equal to what? We let it equal to 0, so x equal to what? Now we can see this equal to 0 means sine 2x equal to 0, yeah? Sine 2x graph like this. So it equal to 0 means what? Here, this point, yeah? This point. So here means x equal to what? Here means x equal to, actually, we do not consider the left point or the right point, okay? We just, here. So here means 2x equal to 1/2 pi. Oh no. So here means what? X equal to what? So here, now we can see that we let sine 2x equal to 0. Sine 2x equal to 0 means x equal to 1/2 pi, yeah? So here x equal to 1/2 pi. X equal to 1/2 pi. X equal to 1/2 pi, so in this interval, here is 0, here is pi. So 1/2 pi is here is 1/2 pi. So here we have two intervals. This interval is 0 to 1/2 pi. The second interval is 1/2 pi to pi. Yeah? So the intervals and f prime and the conclusion. The intervals is here is 0 to 1/2 pi, 0 to 1 half pi in this interval. F prime is greater than 0 or less than 0. So here in this interval, yeah.
On this question, here it was 2x, then 2x is pi 1 to
Yeah.
but here it is only consider as 1.
Here because here now because this graph, okay, this graph is sine the graph of sine 2x. So I think that you just need to remember sine what equal to 0. In this interval, okay, in this interval, sine what equal to 0. The graph of this graph is y equal to sine 2x, and here is 2 pi, here is pi, here is 1, here is minus 1. So here is the graph of sine x. Here is sine x, here is sine 2x. Okay. So sine x, sine what equal to 0? Sine pi equal to 0, yeah? So sine pi equal to 0 means this angle equal to pi, 2x equal to pi, so x equal to 1 half pi, yeah? So here in this interval, f prime, okay? F prime here, f prime in this interval is greater than 0 or less than 0. It's the same, okay? It's the same. We choose an angle in this interval, pi by 4. Pi by 4 here, so minus 4 times sine 2 times pi by 4. This is greater than 0 or less than 0. Here is 1 half pi, sine 1 half pi is what?
Sine 1 half pi is 1.
It's 1, yeah? So minus 4 times 1 is minus 4, so less than 0, yeah? So here is negative. So here is concave down, yeah? Concave down. And in this interval, 1 half pi to pi in this interval, okay? It's the same, okay? We choose a special value in this interval. For example, 3 pi by 4. 3 pi by 4, and we compute minus 4 times sine 2 times 3 pi by 4 is equal to what? So here 2 times 3 pi by 4 actually is minus 4 times sine 3 pi by 2. So sine 3 pi by 2 is what? 3 pi by 2 actually is here, yeah? This point is what? Minus 1, yeah? So it is equal to minus 4 times minus 1, so equal to 4, greater than 0, yeah? So here is positive. So here is positive, so here means it's concave up. So now we can see on the left of 1 half pi is concave down. On the right of 1 half pi is concave up. So the inflection point is what? The inflection point is x equal to 1 half pi, yeah? So now I think that you should keep in mind, okay? You should keep in mind that the increasing, f prime greater than 0 increasing, f prime less than 0 decreasing, f prime greater than 0 concave up, f prime less than 0 concave down. And now, but you can compute the derivative, okay? You can compute the derivative. So now I give you an exercise, okay? So now see page 217. Number 11, okay? Number 11. Number 11. So actually it's easy, okay? It's easy. Now for this function, okay, you find the increasing interval, decreasing interval, concave up interval, concave down interval, and all inflection points, okay? So actually it's very easy, okay? So you have to start. Yeah. On the blackboard. square derivative x. 2x. 3x. 3x derivative. No. Here, this two actually here is 1 plus 3. So here the magnitude is 2 minus 3 by 2. So the result here, you are right. I think that these 2 parts actually should write in minus infinity to in this Here means this interval x belongs to minus infinity to plus infinity. Then in this interval is equal to 2. So in this interval is comparable. 2 greater than 0 is comparable. Yeah? For example, you choose minus 1 minus 1 times minus 1 times positive negative. So here is negative, okay? So here is decreasing. Here is so here is decreasing. No, I think that is very easy, okay? So it's very easy. So first, you need to see the first derivative. The first derivative f prime equal to what? 2x minus 3. You that is equal to 0. So x equal to what? X equal to 3 by 2, yeah? So 3 by 2, so you can see here 3 by 2. So we have 2 intervals. The first interval is interval, and here is f prime, here is conclusion. So the first interval is minus infinity to 3 by 2, yeah? The second interval is 3 by 2 to plus infinity, okay? So the first interval here is greater than 0 or less than 0, where x belongs to this interval. 2x minus 3 is positive or negative? Of course, negative, yeah? So this here is what? It's decreasing, yeah? And now, here for this part, where x belongs to this interval, in this interval, okay? So here, 2x minus 3 is positive or negative? Positive, so here is positive, so here is increasing, yeah? So this is the first derivative. The second order derivative is what? So the f prime equal to what? F prime equal to this prime, yeah? So this problem equal to what? Equal to 2, yeah? So here means what? For any x, f prime equal to 2, yeah? So here means x equal to what? X belongs to minus infinity to plus infinity. In this interval, f prime equal to 2. So here means what? Here means the interval and the f prime convolution. So here is minus infinity to plus infinity. So here is greater than 0. So here is concave up. So here concave up. Under what is concave up? So there is any inflection point. Is there any inflection point? No. Yeah. So here is no inflection point. Yeah. So here is the end of the first section of chapter 5. Okay. Now we turn to the second order derivative. Okay. The second section. Now let's see the page 219. Okay, 219. Okay, now we see this part. This part actually is analysis of functions relative external. Okay, the relative external. The relative external. So the relative external for this part, okay, for this part. Now let's see a graph. For this graph. For this graph, okay, actually it's like a mountain. So here in this mountain, okay, in this mountain we can see here actually we have this is the tops, okay, the tops. Here for this point, okay, this point, the first point, the second point, and here actually it's the tops, okay, the tops, and here the tops of the ears, okay, for this 3 points, the first, the second, the third, okay. For this third, actually it's the tops of the ears. So here means here, for example, this is x1, this is x2, this is x3. For these 3 points, okay, for these 3 points, x1, x2, x3. Actually, we give it a name. This name means that it is the tops of the ears. The tops of the ears. And for this 3 points, okay, here for example, this is x2, this is x4, and this is, this is x4, this is x5, this is x6. Okay, for this 3 points, x4, x5, x6. For this point, actually, it's the buttons of the values. The buttons of the values. So actually here. We can see this point, okay, this point. The first and the second point, the x1, okay, this point. Actually, is the high point nearby, okay, the high point nearby. here is the same, okay? Here x2 is also the high point. The high point, okay? The high point relative to nearby terrain, okay? So here actually is we can see the high points. The high points relative to the high points relative to the nearby terrain, okay? The nearby terrain. So here means the high points relative to the nearby terrain. And the x4, x5, and x6, actually we give it a name. So actually it means the low or the low points. The low points relative to the nearby terrain, okay? Terrain. So here for the x1, x2, x3, we give it a name. A name in mathematics. A name in mathematics means relative maximum. Relative maximum. Okay, relative maximum. And the x4, x5, x6. We also have a name in mathematics. Here means the relative minimum, okay? The relative minimum, okay? x4, x5, x6. Relative minimum means this is the low points nearby, okay? Relative nearby. And the relative maximum means the top points relative to the nearby, okay? So here this is the description. We need to give it a definition in mathematics. So now we have a break. 10 minutes, okay, 10 minutes. Means that fx1, that point is the high point nearby, okay? The high point nearby. So here means on an interval nearby x1, fx1 is the largest value, okay? On nearby, okay? On nearby. And so what's the relative minimum? Relative minimum means that the point is the smallest value. The smallest value nearby, okay? The smallest value nearby. So here now we give the definition. The definition is like this. A function f is said to have a relative maximum. At x0, if there is an open interval, containing x0, on which fx0 is the largest value, This means that fx0 greater than or equal to fx for all x in the interval, okay? So this is the definition of the relative maximum, okay? So it's the same, the relative minimum. A function f is said to have a relative minimum. Minimum means at x0, if there is an open interval containing x0, on which fx0 is the smallest value. Okay, the smallest value, that is fx0 less than or equal to fx for all x in the interval, okay? In the interval. So here means that relative maximum means fx0 is the largest value, okay? The largest view nearby is the relative maximum. Relative minimum means the smallest view nearby. Okay, the smallest view nearby. So here, this is the definition. Okay, so this is the definition. Now we give some example. We give some example. For the first one, we can see y equal to x squared. For this function, okay, for this function, we know the graph. The graph of this function actually is like this. Here is x, here is y. So here is y equal to x squared. Y equal to x squared. Now it's easy to see that. The point 0 is the relative what? The x0, this point is the relative minimum or maximum. Minimum, yeah. So this point 0, okay, x0 equal to 0. This point is the relative minimum. And now we can see this point, okay? Now we can see this point. Actually the derivative fx equal to x squared, and f prime x equal to what? F prime equal to 2x. So now we can see f prime x0 equal to 2 times x0 equal to 0. So here means f prime, okay, the derivative at the relative minimum equal to 0, yeah. So this is the first example. The second example, now we can see y equal to sin x. For this function, okay, for this function, now we plot the graph. We just see in this interval 0 to 2 pi, okay, 0 to 2 pi, this point, this interval is like this. Here is 0 to 0 pi 2 pi, okay. Here is x, here is y. So this point is 1/2 pi. This point is 3 pi by 2. So in this point, okay, this point actually is the relative what? Relative maximum, yeah. So x1 equal to 1/2 pi actually is the relative maximum. And the second point, 3 pi by 2, this point actually is the relative what? Minimum, yeah. So x2 equal to 3 pi by 2 actually is the relative minimum. Now let's see the derivative at these 2 points. Okay. So fx equal to sin x. So f prime equal to what? F prime equal to cosine x. Yeah. So now let's see f prime x1 equal to what? F prime x1 actually is cosine 1/2 pi. Yeah. Cosine 1/2 pi is what? Cosine 1/2 pi 0, yeah. Cosine 1/2 pi 0, and f prime x2 equal to what? Cosine 3 pi by 2, okay. Cosine 3 pi by 2 is what? It's also 0, yeah. So from these two examples, we can see at the minimum or at the relative minimum or at the relative maximum, the derivative equal to 0, okay? Equal to 0. So it's right, or it's all right. Now let's see the third derivative, the third example. For this example, y equal to the absolute value of x. The absolute value of x, the graph is what? It's V-shaped, yeah? It's V-shaped. So it's like this. It's like this. Here is x, here is y, yeah? So here is y equal to absolute value of x. For this point, for this graph. So this point is the relative point. 0, this point is the relative maximum or minimum? Minimum, yeah? So x0 equal to 0 actually is the relative minimum. So the relative minimum now not the same, okay? So the derivative at this point is what? The derivative of this point. So actually the derivative at this point. Actually we can see the left derivative is minus 1. The right derivative is 1. Yeah. So the left derivative not equal to the right derivative. So means that this derivative actually does not exist. Yeah. Does not exist. So here means what? Here means from these three examples means that at the relative minimum or at the relative maximum, the derivative equal to 0 or the derivative does not exist. Yeah? Yes. So at the minimum or at the relative minimum or at the relative maximum, the derivative equal to 0 or the derivative does not exist. So now we need to give a name for this point. Okay, for this point. For the derivative equal to 0 or the derivative does not exist, we give it a name. Means in mathematics this name is critic points. Critic points. Critic point, okay? Critic point, we have two. So what's the definition of critical point? The critical point means that the derivative equal to 0 or the derivative does not exist. Okay? So here means f, the critical point x0 means f prime x0 equal to 0 or f prime x0 does not exist. Does not exist. Okay? So this is the definition of critical point. Critical point means the derivative equal to 0 or the derivative does not exist. Does not exist. And for this case, okay, for this case, actually in mathematics we have another name, means the stationary point, okay? The stationary point. So the stationary points, what's the definition? The definition means f prime x0 equal to 0, okay, equal to 0. So the stationary points means the derivative equal to 0. Okay. So it's easy to see what's the relationship between the critical point and the stationary point. Actually, the stationary point is the critical point, yeah. But the critical point is not a stationary point, yeah. So here means that if we have assigned this set, means the stationary point. So this point, this side actually belongs to the transfer, yeah. And now you can see here at this point, we can see the tangent line. The tangent line actually is a plane. Okay, this is also a plane. So here means this point, and this point, x1, x2, and x5. This point. Okay, the derivative equal to 0. So here means what? x1, x2, and x5 actually is the stationary point. And now for the x3 and x4, okay? x3, x4, I think that it's easy to see the left derivative and the right derivative, they are not the same, yeah? They're not the same, and this point is the same. Actually, for this point, it's something like this point, okay?
Yeah.
Something like this point. Yeah? So actually for this point and this point, they are critical point. This x3, x4, they are critical point, but they are not stationary point. Okay? So x3 and x4, they are critical point. They are critical point, but not stationary point. Okay? But not stationary point. A lot stationary point. Okay? So here we can see that. So we have a conclusion. Okay? The relative minimum or relative maximum, a function of the relative minimum or maximum must the critical points. Okay, must the critical points. Must the critical points. So we have a conclusion. So we have a result. Let's see the example. Now let's see the example. Find all critical points. Find all critical points of the function. Of the functions. The first function is fx equal to x cubed minus 3x plus 1. The second function is gx equal to 3x to the power 5 by 3 minus 15x to the power 2 by 3. Okay, 2 by 3. For these two functions, okay? For these two functions, find all critical points. Find all critical points. So here means you need to find what? Find the derivative and let the derivative equal to 0 and find the derivative does not exist. Okay? Does not exist. So here for this function, okay? For this function, the first function. Now, the last point, the last point. So the derivative of this function is what? U.
X squared.
So f derivative equal to what?
X squared.
X squared.
3x squared.
3x squared and what?
X
minus what?
3.
Minus 3, yeah? So here is easy to see this function. So we let this derivative equal to what? Equal to 0, yeah? Equal to 0, so we can find x equal to what? X equal to, actually here means this equal to what? Equal to 3 times x squared minus 1, yeah? That is equal to 0. That is equal to 0.
X minus 1.
So x squared equal to 1. So x equal to what? X equal to 1 or x equal to minus 1, yeah? So for this, so here means that x equal to 1 and x equal to minus 1. X equal to 1 and it means that 1 and minus 1 and minus 1 are the critical points. Are the critical points of fx, yeah? Of fx. So now for this function, okay? Actually this function is definable, yeah? Definable. So we do not have the points. The derivative does not exist, okay? So 1 and the minus 1 are all critical points, okay? Are all critical points of fx. So I think that this. Now for the second, for gx, okay? For gx. Gx equal to 3x to the power 5 by 3 minus 15 x to the power 2 by 3. Okay, 2 by 3. So here for this function, now the same, find the derivative. So g prime equal to what? G prime equal to 3 times 5 by 3 times x to the power 5 by 3 minus 1, yeah? This is the first part, yeah? The second part, minus 15, here is times 2 by 3 and the x to the power 2 by 3 minus 1, yeah? So here equal to 3 times 5 by 3, here is 5. Here is 5. 5 times x to the power 5 by 3 minus 1. So here is 2 by 3, yeah? And minus 15 times 2 by 3. Here is 10 x to the power 2 by 3 minus 1. So minus 1 by 3, yeah? Minus 1 by 3. So here we take out 5 and the x to minus 1 by 3. So it's equal to, here is x minus 2. Yeah? So we take out 5 times x to the power minus 1 by 3. Okay? So it's equal to x times x minus 2. Okay? So we rewrite it in, so here is 5 times x minus 2. X here is minus 1 by 3. So here we write it in denominator. Here is 1 by 3. Yeah. So now first we let it equal to 0. We let it equal to 0. We can find what? We can find x equal to 2. Yeah. X equal to 2. So here means 2 this point. Okay. To this point actually is a critical point. It's also what? It's also a stationary point. Yeah? Because at this point the derivative equal to 0. Yeah? So here means what? So here means actually g prime. Okay, g g prime 2 equal to 0. So here means 2 is the stationary point. Is also the critical point. Yeah. Also the critical point. So now let's see if the denominator equal to 0. If the denominator equal to 0, so now we can see this undefined. Yeah, this is undefined. So here means what? Here means g prime at the point 0. G prime, okay? G prime at the point 0. This actually is equals to infinity, yeah? Infinity. So here means what? Here means g prime 0 is not exist, yeah? Does not exist. Does not exist. Does not exist, so here means what? 0 is the critical point, yeah? 0 is the critical point, but 0 is not the stationary point, okay? It's the critical point. So the all critical point is what? It's 0 and 2, okay? So 0 and 2 is the all critical point. The all critical points of the function gx. Of the function gx. Yeah? How to what? 2. Actually, you can see g prime equal to here. Yeah? So g prime 2 equal to what? G prime 2 actually equal to 5 times 2 minus 2 divided 2 the cube root. Yeah? So it equal to what? 0. Yeah? So the stationary point is the derivative equal to 0. Yeah? So, let's see that. Yeah? Now, actually, we can see here x to the power 2 by 3. We can rewrite it in what? We can rewrite it in x here equal to 5, x 2 by 3. We can 2 by 3 actually equal to what? Equal to minus 1 by 3 plus 1. Yeah? They are the same. Yeah? 2 by 3 equal to minus 1 by 3 plus 1. Yeah, so here we can see here is minus 1 by 3 plus 1. Yeah, so minus 1 by 3 actually is x to minus 1 by 3 times x. Yeah, so minus 10x minus 1 by 3. Yeah?
Understand.
Now we do access. Okay, now we do access. Now we do access locate, okay? Locate the critical point. The critical point. Locate the critical points and identify, okay? And identify which critical point. Which critical point are stationary point, okay? Stationary points. So the first function is fx is f plus fx equal to 3x cubed times x plus 1 squared So the second gx equal to 2x plus 3x to the cube root, okay? The cube root. Now we do these two, okay? We do these two. So locate the critical points and identify which critical points are stationary points, okay? So now you the first one, okay? First one, and you the second one. The second one. Okay? The first one. The first one. Fx. Here, g prime equal to x plus here 2x directly into so that is to 0. Here means that 0 is the only critical point, but it's not square root of the cube root. Positive. 1 by positive. So 2 plus positive. Also positive. So here means for many is always greater than 0. Always greater than 0. So here means that we do not have the x such that g plus x equal to 0. Because g plus x is always greater than 0.
So this is not zero.
It's not equal to 0. Not equal to 0, but we can see here, when n equal to 0, this is undefined. Yes. Undefined means that g plus 0 is undefined. It's undefined means that as long as it is so easy. Yeah, so 0 is so I think that we can try to get here is what? Here is x cubed times 2x. 2x cubed Now let's see, okay? So I think that is not one hard, okay? I think it's easy because the first you can compute the derivative, yeah? The first, okay? The basis is I give you a function, you can compute the derivative, okay? This is one important, but most of you cannot get the answer, get the right answer, okay? Sometimes I think that you can, but sometimes you do not careful, okay? You do not careful. So here now, let's see the first one. Here for this one, gx equal to 2x plus 3x the cube root. So the derivative is what? The derivative is this part derivative, yeah? 2x derivative is what? 2, yeah? So 3x cube root, the derivative is what? Is 3 times 1 by 3. And the x 1 by 3 minus 1, yeah? So the result actually is x to the power minus 2 by 3, yeah? So the derivative actually is 2 plus x minus 2 by 3, yeah? So we can see that minus 2 by 3, we can rewrite it by 1 by x to the power 2 by 3, yeah? X to the power 2 by 3, we can rewrite it by x squared, the cube root. The cube root of x squared, yeah? They are the same, yeah? X to the power 2 by 3 actually equal to the cube root of x squared. So now we can see if x is not equal to 0, if x is not equal to 0, we can see x squared is what? Is positive, yeah? X squared, if x is not equal to 0, okay? If x is not equal to 0, x is not equal to 0, we can see x squared greater than 0, yeah? So the cube root of x squared is also positive, yeah? So 1 by positive is also positive, yes? 2 plus positive. So here means what? Here means what? G prime x is always greater than 0, yeah? Always greater than 0. So there is no point. There is no point such that G prime equal to 0, okay? There is no point such that G prime equal to 0. So here means that for this function, there is no stationary points. For this function gx, there is no stationary point. Okay? Because for all points, G prime is greater than 0. Now, so for this function, there is no stationary point. For the second, here we can see the derivative equal to here. So we can see this function actually is undefined on which point. Here we can see this part is the denominator, yeah? Denominator cannot be 0, yeah? Cannot be 0, so here means that x squared cannot be 0, yeah? Means x cannot be 0. X cannot be 0, so here means G prime is undefined on 0, yeah? Undefined on 0, so here means what? G prime 0, this does not exist. Does not exist. So 0 is what? 0 is the critical point. So 0 is a critical point, but not stationary point. Okay. So 0 is the critical point, but not the stationary point for this function. Okay. Now for this function fx. For fx here, x cubed times x plus 1 squared. So of course you can open it. Okay, you can open it. So open it here is x squared plus 2x plus 1. So times x cubed. Times x cubed. So x cubed times x squared, x to the 4th power, to the 5th power. X cubed times 2x. So here is 2x to the 4th power. And x cubed times 1. So here is x cubed. So the derivative this part is 5x to the 4th power plus 8 to the x cube plus 3x squared. Yeah. So we can take out what? We can take out x squared. So x squared here is 5x squared plus 8x plus 3. Yeah. That is equal to 0. That is equal to 0. So here means this part equal to 0 or this part equal to 0. Yeah. X squared equal to 0 means x equal to 0. Yeah. 5x squared plus 8x plus 3. This part equal to 0. 5x squared plus 8x plus 3. This part equal to 0. X equal to what? Actually, for this part, x equal to what? Equal to minus 1 and x equal to what? Minus 1. Yeah. So here actually this part you can write it by 5x. Here is x minus 1, 5x minus 3. Yeah. You can. We have a factorization. The first factor is 5x minus 3. The second factor is x minus x plus 1.
Plus.
Oh, so here plus. I'm sorry. Okay. Here's plus. Yeah.
Yes.
So here we can see x equal to minus 1 or x equal to minus 3 by 5. Yeah. So these 3 points are the critical point. Yeah. We can see that for this function, okay, for all points we have the derivative. So there's no point such that the derivative does not exist. For all points, the derivative exists. So, and we let it equal to 0. So we can see that 0 minus 1 and minus 3 by 5 are stationary point. Okay. Of course, the stationary point. Of course, is the critical points. Yeah. Now that's all. So I think that I felt that most of you are not familiar with the derivative. Okay. And so now I think that you should do familiar with the derivative and familiar with the increasing, concave up, concave down, and the critical points, stationary points. Okay, and now I think that it's very important that you should do the exercise of this book. Okay, of course, I tell you. Okay, I tell you that the exam, the exam will choose from the exercise, okay, from the exercise. So if you do the all exercise and you get the right answer, I think that you can get the full score, okay, 100 score on the usual exam, okay. The usual exam will choose from the exercise, okay. Of course. So I think that you should do it, okay? Do it. If you have any question, you can find me on Monday night, okay? So the class is over, thank you.